音声をお聞きいただくことができます。それでは、第2部の開始よろしくお願いいたします。
はい、それではこれから第2部を開始をいたします。第2部はパネルディスカッションということで、OECD からの講演、日本企業2社からの事例紹介と、そのお三方によるディスカッションという構成になってございます。モデレーターは IGES の青木主任研究員が務めさせていただきます。では、ここからの進行は青木研究員よろしくお願いいたします。
はい、ありがとうございます。ご紹介いただきありがとうございます。IGES の青木でございます。それではこれから第2部始めさせていただきたいと思います。まず、本第2部の目的ですけれども、循環経済ですが、国連などの国際社会の議論のみならず、日本含む多くの国においてかなり政策面にも反映されてきたというふうに考えております。で、今回、事例で、発表させていただきました通り、企業の様々な試みですとか、実際のビジネスの展開も始まっており、まさに皆様、実施のフェーズに入っているなというふうに日頃感じております。はい、この第2部ではですね、こういった昨今のサーキュラーエコノミーの盛り上がりを受けて、循環を念頭に置いた新たなビジネス、サーキュラービジネスやサーキュラー製品の開発を行った企業に、企業のサーキュラーエコノミーへの方針も含めた事例を紹介していただくとともに、サーキュラーエコノミーの実践上の課題について議論いただくということを目的としております。本セッションでは、ご紹介にありました通り、OECD 経済協力開発機構のシャドゥル・アグラワラ OECD 環境局環境経済統合部課長から、資源やプラスチックの消費、生産に関する長期的な展望、サーキュラーエコノミーの実現に向けたデジタル化等の役割についてご報告いただきます。続いて、注目事例集2022に掲載された、中から、旭化成様、三菱ケミカル様の2社に掲載された事例や循環経済の取り組みについてご紹介をいただきます。その後、パネリストの皆様と共にパネルディスカッションを進めていくという、形になっております。それでは、パネリストのご紹介をさせていただきます。まずは、海外機関からのゲストということで、シャドゥール・アグラワラ OECD 環境局、環境経済統合部課長、にいらしていただきました。アグラワラ課長は環境経済モデル、実証分析、循環経済、貿易と環境に関連する業務を主導されていらっしゃいます。グローバルプラスチックアウトルック、グローバルマテリアルリソースアウトルックなど OECD の機関出版物をリードされておられます。2002年より OECD にて OECD 事務総長上級顧問、気候変動シニアエコノミスト、経済課題への新たなアプローチのコーディネーターを歴任されております。プリンストン大学で博士号を取得された後、プリンストン大学、コロンビア大学、ハーバード大学で研究職を歴任され、気候変動に関する政府間パネルの、筆頭著者などを務められておられます。企業からのパネリストとして、旭化成井出洋一郎デジタル競争本部資源、循環プロジェクト長に、お越しいただきました。1993年に旭化成に入社され、2018年よりサーキュラーエコノミーの企画に携わられ、2020年より資源循環デジタルプラットフォームのプロジェクトを立ち上げられ、2022年1月より現職に就かれております。もう一方、ご到着が、後ほどということですけれども、三菱ケミカル株式会社真渡り、健一郎グリーントランスフォーメーション推進本部長に、来ていただきます。真渡り本部長ですが、1998年に三菱化学入社以来、主に石油化学分野を歩まられ、ポリエステル原料となる製品販売、原料購買、ナフサ調達などを担当されました。2020年4月に、現組織の前身であるサーキュラーエコノミー推進部の発足メンバーとして組織立ち上げから参画され、2021年4月より現職に就かれておられるということです。それでは、3名のパネリストの皆様、本日はどうぞよろしくお願いいたします。では、最初のプログラムとして、OECD アグラワラ課長から、サーキュラーエコノミーに関する、ご講演をいただきます。 So thank you very much for joining us today, Dr. Agrawala. So we are very honored to have you here today. So we are very much looking forward to hearing the OECD observation on the circular economy and have analysis on your analysis. So thank you very much, Dr. Agrawala. The floor is yours.
Thank you very much, Mr. Aoki, and thanks to IGES to give me this opportunity. I really look forward to participating in this discussion. I'm going to share my slides now. Okay, I hope you can share, you can see my.
Yes, we can see your slides.
Excellent. So in my presentation, I'll be talking about the global outlook for resources and plastics, and that's going to draw on publications we recently came out with. The first is the Global Material Resources Outlook to 2060, and more recently, we came out with 2 volumes of the Global Plastics Outlook. But I'll then draw on these outlooks to address a question which is closer to the goals of this workshop, which is looking at the role of digitalization and new business models to foster a circular economy. So, sorry. Okay, so before I start on the outlooks, I wanted to situate this discussion based on 2 views on the problem of resources, because this has been talked about for at least 50 years. Natural scientists and economists have often come to opposite conclusions with regard to the issue of resources. We recently celebrated 50 years of this landmark publication called Limits to Growth, which painted a rather bleak picture of the world running out of resources and all kinds of social and economic consequences that would result from it pretty much by this time. Now, countering that argument was a book published by an economist who basically argued that as resources become scarce, we would be, the prices would go up, and that'll lead to incentives for innovation and exploiting resources which were before not as viable. And so the argument was that there would be innovation, there would be new sources being discovered, and we won't really have a resource problem. Now, since then, I'm glad to say that economists and natural scientists have come to more convergent conclusions now. And there's a recognition that maybe we might not be running out of resources in the absolute sense, but what we are running out of is the capacity of our natural system to absorb the waste we are generating from the use of resources. So the debate has shifted from material scarcity to planetary boundaries. And at the same time, economists have also come to acknowledge that markets are not always efficient, and there are significant externalities with regard to the use of resources which are not priced in and need to be taken into account to prevent environmental damage. So that's a more nuanced view and a more convergent view between the physical scientists and the economists. Now, it is in that context that we did these outlooks, which I'll be talking about. So first, let me just highlight some of the key findings from the material resources outlook. And according to our outlook, the use of material resources is projected to double by 2060, but the growth will differ across materials and across countries. So this is the picture that we have for the OECD, where in 2017, roughly 20 gigatons of resources were consumed. And we have broken the resources into 4 categories: non-metallic minerals, which are largely construction materials, metals, fossil fuels, and biomass. And you see the projections into 2060 for the OECD. And this is the picture for the BRICS economies, where in absolute terms, the consumption is a lot higher even in 2017. And you see the growth projected to 2060. And finally, we have a category we're calling rest of the world, where the drivers are primarily in sub-Saharan Africa, where we are starting from a much lower base of consumption of resources in 2017, but the rate of increase is much more rapid than for the other 2 categories. Now, I'm not going to go into all the details for it, but the main point I wanted to make was that, yes, projected use of resources is going to double, but it depends upon which material we're talking about. It also depends upon which set of economies we are talking about. Now, of course, we don't really care about tonnage of resources. The real problem is the environmental consequences from the consumption of resources. One of the consequences is greenhouse gas emissions, because the greenhouse gas emissions linked to the material resource cycle are already very significant. So this is the picture in 2011 of the emissions by different sectors, and the emissions related to materials management are linked to agriculture, energy supply, and industry. And as you can see, they are the bulk of the greenhouse gas emissions even in 2011. Now, if you look at the projections to 2060, this is the picture. And so roughly 50 gigatons of carbon dioxide equivalent of emissions in 2060 would be related to the materials management cycle. 9% of total greenhouse gas emissions in 2060, according to our projections, are associated with the extraction and production of just 7 key metals. 12% of total greenhouse gas emissions are associated just with concrete. And as I said, 50 gigatons of carbon dioxide equivalent emissions overall are associated with the material cycle under business as usual. Now, greenhouse gas emissions are one environmental impact, but materials use also has a wide variety of other impacts. And here we try to capture the impacts of different materials across a whole range of environmental vectors, looking at toxicity in different parts of the natural system, but also looking at ozone layer depletion, impacts on land use, and so on. And these impacts are scaled relative to the most polluting material. And this is the picture for concrete in 2015. And you can see that the impacts are different depending upon which impact category we are talking about. And these are the projections for 2060. And you can see that across all the metrics, these wide impacts are going to double or more by 2060. This is the picture for iron, a very different picture from concrete. But again, in 2060, all these impacts are projected to increase very significantly. Another point I'd like to make is that the impacts of primary materials and secondary materials are very different. So this is the picture for zinc, primary zinc, and this is the picture for secondary zinc. This is the picture for nickel, primary nickel, and this is the picture for secondary nickel. If there is a case for a circular economy, this is it. It's because secondary materials have vastly reduced environmental impacts across a whole range of dimensions. That's the environmental case for a circular economy. Now, let me briefly also mention what the outlook is for plastics. So according to our projections in the Global Plastics Outlook, the global plastics use is on course to almost triple by 2060. So in 2019, we used 460 million tons of plastic. And by 2060, we are projecting we'll be using 1,230,000,000 tons of plastic under business as usual. And this is the picture in different parts of the world. Most of the OECD countries are projected to see a doubling. But for sub-Saharan Africa, we see an increase of almost 6.5 times. For India, 5.5 times, and so on. So the more dramatic increase in use will be in key emerging and developing economies. Now, again, talking about environmental consequences, if we look at plastic waste, we are projecting plastic waste is also going to triple, and half of it is going to continue to be landfilled. So this is the picture of plastic waste generation from now to 2060. 15% is, we project it's going to be mismanaged by 2060. It's currently 22% now, so that's the good news part of the story. Roughly 50% will continue to be landfilled, and that's not going to change. We expect roughly 18 to 19% incinerated, and that percentage is also going to remain more or less constant. And then we have the share which is being recycled, which is going to roughly double from 9 to 18%. So I'm not going to go into too much more detail, but what are some of the key messages from these two outlooks? So the first point is that despite structural and technological change that's going to take place, global plastic materials and plastic use will respectively double and triple by 2060 with widespread environmental impacts. Reducing use and enhancing circularity are both needed to reduce environmental impacts. Now, given the stark differences between materials, we need greater granularity within circular economy policies and coherence with other policies, including on climate change, trade, innovation, and taxation. And finally, public policies should also enable and not stand in the way of scale-up of circular business models to deliver environmental benefits and mitigate any unintended effects. In this context, digitalization also has a very critical role to play. And now I'm going to say a few words about both circular business models and digitalization and how they play a role in the circular economy. So this is the second part of my talk. What role can digitalization and circular business models play? So first, talking about digitalization, the digital technologies have an important role to play in all aspects of the material cycle. So, I'm just giving a few illustrative examples. So, for example, tracking of asset wear and tear and identifying where there are opportunities for repair and material recovery is one area where digital technologies are already playing a very important role. This is an example from the automotive sector about intelligent tracking of assets. Then the sharing economy, the digital platforms are obviously playing a very important role in fostering the sharing economy and the implications for reduced material use or promoting circularity. And then finally, we have artificial intelligence and other technologies which are already reshaping the landscape in recycling and promoting enhanced material recovery and also reducing the costs of recycling. So these are just some illustrative examples where digital technologies are already playing a role in contributing to circularity. And these are the logos of all kinds of companies which are operating in different parts of the material cycle where we could find examples of them applying digital technologies. The time is too limited for me to talk about examples, but perhaps we'll be hearing from some of the private sector companies later, and we'll be hearing similar examples from them. Now, coming to circular business models. So we did a publication a couple of years ago where we identified 5 different kinds of circular business models. So these business models are essentially built around closing different material loops. So these are some of the higher value loops, including repair, reuse, remanufacturing, and of course, recycling, which is the lowest value loop. There's also industrial symbiosis. Another business model is on sourcing renewable or bio-based inputs. Another one is on the sharing economy. And finally, we have another business model, which is on product service systems, so replacing products by services. So these are, again, logos of several companies which have circular input models where they are sourcing raw materials to renewable or recycled materials. Then waste to value is a business model which is very old. It also includes recycling, of course, but these are some of the companies which are more using innovative techniques and developing new business models on the waste to value side. Then we have models which are extending the lifespan of models. And again, you have several logos there, and platform models where you can recognize logos like the Airbnb and so on. So these are the digital platforms where we are increasing the utilization of assets. And finally, products as services, where companies are replacing products, the sale of products, by the supply of services, reducing the material footprint. Now, clearly, a lot is happening in this space, but what are some of the challenges? One key challenge that we found in our review of the business models and how far they're penetrating is that the market penetration of many of these kinds of business models is still very limited. Now, there are some examples like chemical leasing, which is in the top category, the product service system, where in the automotive sector, the market penetration is already very high, 50 to 80%. But then if you look at many of the other models, first of all, I must acknowledge that getting data on this kind of information is very, very challenging. But these are our estimates based on available sources that generally a majority of these business models have market penetrations of less than 15%. So there's clearly a big opportunity, but there are clearly also a number of significant bottlenecks that need to be addressed before we have adequate scale up. Just giving you some examples of variable scalability. So one example I'd like to give is mature business models. So here, recycling and secondary materials is something which has existed for a very long time. This is the case of metals. So proportion of secondary metals in global output, and the charts are about steel, aluminum, and copper. And you can see that the share is relatively flat over the last several decades. So, we reached a level of share, which is between 20 and 30%, or in the case of copper, between 10 and 20%, but we have not been able to increase the share over time. And this points to a number of bottlenecks, both technological, but also related to policy, which need to be addressed if we need to increase the share going forward. A different example is one of these new business models. So here it's the idle capacity model, and we're looking at Airbnb, where you can see a very rapid increase in the last several years, and that increase is projected to continue. So here it's a very different picture in terms of ramp up. But again, one big question is, what is the overall environmental impact of some of these platforms? And to be honest, it's not quite clear. Clearly we are using idle assets more effectively, but it might lead to increased travel. It might lead to secondary impacts, which are not fully quantified. So there's a lot more work to be done to look at the full environmental impacts of some of these business models. This is, again, looking at car sharing scheme. And again, it's a very similar picture to Airbnb. But again, there's a big question mark over, in the case of car sharing schemes, the question is, what demand is it displacing? Is it displacing demand from personal automobiles to car sharing, in which case the environmental impact might be positive. But if it's taking demand away from public transport, then the picture might be very different. Another point I'd like to make is that when we are trying to close loops, the goal is to close loops globally across jurisdictions. We don't necessarily have to close loops within national jurisdictions. And sometimes it might not even be cost efficient to close the material loops in each jurisdiction, because we might not be able to exploit the economies of scale. We might not be collecting material at scale. We might not have the technologies. So it may be important to try to close these loops across borders in many cases. And these are some of the examples. This is for remanufacturing, where you have, this is from the construction sector, where they take the cores and important parts of this construction equipment and ship it across borders so that they can actually repair it in a cost-effective manner and reuse it. A picture is similar for medical devices, photocopiers, and so on, where there may need to be cross-border flows for reuse as well as repair or remanufacturing. And in the case of high-tech electronics, often it's a question of material recovery of rare earths, for example, where we may need to have material at scale to be able to effectively recover the materials. And that might again require these products to be transmitted across borders. Now, the challenge here is the alignment between restrictions on trade in waste and some of these streams, which may not be waste, but are either used products or materials, resources, which can be used again. And that's the alignment where public policies need to play a very important role. So one final point I'd like to make is the evidence of environmental impacts of circular business models is somewhat mixed. So these are some of the channels through which circular business models reduce the environmental impact. So if you're talking about waste as value models, what they are trying to do is reduce the demand on primary materials, and that leads to reduced environmental impacts. And you have a whole range of environmental impacts. I'm not going to run through the list here, which result from circular business models. But I'd like to point you to the picture in red, where the impacts might be negative. So if you're talking about waste as value, we are also going to spend energy to collect and recycle. So that needs to be taken into account. If we are talking about extending the usable life of products, it may also mean that inefficient products may actually have a much longer use life. And so the environmental impacts in the use phase might be worse than if more efficient products were to come to the market. So the point is that we need to be conscious of this more complex environmental picture when we are looking at overall environmental impacts. And so now coming to some concluding observations. First, I think, although there's a lot of talk about circular business models now, the activities underlying many circular business models are not new, but they are more widespread, diverse, and sophisticated now, and partly as a result of the availability and scale-up of digital technologies. Life cycle assessment literature indicates that circular business models in general have a lower environmental footprint, but there could be offsetting factors such as burden shifting, as well as rebound effects. And realizing the environmental benefits of these business models would require more widespread adoption of these business models. And in some cases, this is already taking place, but in other cases, business models are relatively mature and are not increasing their penetration. And we need new policy frameworks to address barriers to further adoption. Final slide, what is the role of policy? I think one key thing where public policies can play an important role is pricing of environmental externalities to disincentivize a linear economy and make circular business models more competitive. Second, to better align international trade and circular economy policies to promote closing of loops across borders. Then we also need to promote the supply of circular products. So here, design standards, extended producer responsibility schemes, as well as targeted R&D funding can play an important role. And finally, we also need to promote the demand among consumers for circular products. So there could be differentiated VAT rates, for example, reduced VAT for repair, recycled content mandates, product labeling standards, and green public procurement. These are some of the policy tools governments have at their disposal to promote the scale-up of circular business models. So that is the end of my presentation. Thank you for your attention, and I look forward to the discussion.
Thank you very much, Dr. Agrawa, for your comprehensive, very informative presentations. We are very much looking forward to having a panel discussion with you later. はい、ありがとうございました。資源使用やプラスチック使用に関する将来展望ですとか、それに伴うGHG 排出をはじめとした環境影響、に関する定量的分析ですとか、あと二次資源の使用が環境影響の削減のポテンシャルが非常に大きい点ですとか、サーキュラービジネスモデルの成長の余地の、ご議論、またサーキュラーエコノミービジネスモデルによる環境影響、良い環境影響の面も負の環境影響の面も包括的に整理いただいたと思いますし、最後にデジタライゼーション、デジタル化ですとか貿易ルール、政策の役割など非常に包括的にまとめていただいて非常に参考になったかと思います。ありがとうございました。